Now coming to this statistics. Now what is meant by statistics? Statistics is nothing but measure and analyze. Okay, statistics is the meaning of measure and analyze the data. You have to measure the data and you have to analyze the data. A combination of measuring and analysis is called as statistics. Within the statistics, we are having the variables. So whatever I have discussed in the last class, during the pandas, I have told you the variables. Like we are having continuous variables and discrete variables. Now any particular column, any column names, whatever the features or column names we are having, the columns are called as variables. So we are going to have the multiple variables in the real life. So in that variables, for example, there is a gender column. Okay, gender is the variable. For this variable, we have to analyze, measure the values. Measure the values means how many categories are there, and from each category how many values are there. That is, we have to apply the value counts for this. You have to apply the value counts. By applying the value counts, you are going to get each category and their number of counts on the each category. Similarly, if you are having with respect to one more different type of variable, continuous variable is that means there you have to measure the mean value or with respect to median value or something differently. So for different types of data or different types of variables, the measures will be different. For continuous variable, the measures are different. For discrete variable, the measures are different. We can't apply the measures, whatever we are doing for the discrete on the continuous. For the continuous, we can't apply on the discrete. So first we have to understand the types of variables. So we are having the continuous variable along with the discrete variables, right? So now whatever the variables we are having in terms of quantitative data, qualitative data. Quantitative means quantity. Quantity means in terms of numerical. Quan means whenever you see the word of quan means quantity. Quantity. Qual means quality. Just you add the ITY for that. Quantity, quality. So quality means you are going to say either good, bad, like this. Quality you are going to say based on the some kind of text data. Whereas quantity you are going to say based on the numerical data. So quantitative variables are nothing but numerical variables. Quality variables are called as with respect to discrete variables, categorical variables. Now here we are having with respect to in the categorical nominal and ordinal. Nominal means where there is no ordering. Means for example, hair color is there, red, brown, blue. There is no order between them. Whereas for ordinal data, you are having the order. Certain order will be there. For example, A plus B, letter grades are there. Everything are not equal, right? They are having the difference. Here, every brown color, red color, whatever the hair is there, whatever the hair color is there, everything are same. You can't say red color is best than the brown color or brown color is better than the blue color. You can't say. That is from your perspective. For others' perspective. But if you see this letter grades from every perspective, this is common. This is common from every perspective. Everyone knows that A grade is better than the B grade. B grade is better than the C grade. Not only you, not only me. Any person in the world knows this one. That is common for everyone. Whereas this one, from perspective to perspective, the order will change. There is no natural ordering between them. This is having the natural ordering between them. Right? Now, whereas discrete count variable, continuous variable. This is in the text data. Any data in the text means you are having ordinal and nominal. This is for text data. That is for quantity data, qualitative data. For qualitative data, this is applicable. That is nominal and ordinal. Whereas if you are coming with the quantitative data, that is numerical data, you are having with respect to discrete count or continuous. Discrete count or continuous, where discrete count is with respect to where you are not having the decimal values. That is number of dogs if you consider. 1, 2, 3, you can say 1.1 dog, 1.2 dog, you can't say like this. Similarly, weights, where you are having with decimal values is called as continuous data. So in the last class, we already discussed this one. The data is basically two types. One is called as cross-sectional data and time series. Within the cross-sectional, you are having with respect to continuous and discrete. Within the discrete, you are having discrete count and discrete categorical. Within the discrete categorical, you are having nominal and ordinal. Right? This is the chart which we have discussed. Now, this one is in the numerical format. This will be in the numerical format. Count also will be in the numerical format. So the same data, cross-sectional data, whatever the cross-sectional data, can I write like this in the numeric and text? Within the numeric, one is continuous. One is discrete count. And the same text, whatever the text is there, this text is with respect to ordinal and nominal. The same flow chart, you can write either like this or like this. But this count is also always called as discrete count. You have to use the word called as discrete count. It is a discrete variable. Discrete count. For example, in this class, for example, I'm having like this number of mobile phones. One student is having 0 phone. One student is having one phone, one mobile phone, one student is having 2, 0, 1, something like this. Now, how many unique categories are there? 3 categories. What are those 3 categories? 0, 1, 2. How many zeros are there? How many ones are there? How many with respect 5? And how many with respect to 2s are there? So this is discrete variable. Though it is said in the numerical format is available also, it's a discrete variable. Since it is a discrete variable, I am applying the value counts on this. Value count means each category and their count. The same mobile was written in the letters like 0, ONE, ONE, ONE also. This is also TWO, TWO, 0, ZERO, ONE. This is English, this is number. But both are discrete only. Though it is in this format, categorical format or count format, both of them are discrete only. Whereas continuous variables are completely different. So for each type of data, we have to apply in a different way. The flow chart will be the side like this. The entire cross-sectional data was divided into 2 parts, that is numeric and text. You can write the same flow chart like this. Now some people will write in a different way. The flow chart they will write in a different way. Data, cross-sectional and time. Up to here it is common. For anyone it is common. Up to this is common. So cross-sectional and time. Any structured data will have like this only. Unstructured data again different. Structured data means cross-sectional and time. Now same cross-sectional data and time. The same cross-sectional data, instead of writing the word called as numeric, they will write the word called as quantitative. And second one is qualitative. I have written numeric and text now. Numeric is called as quantitative. Within the quantitative, continuous discrete count. Qualitative means text. This is qualitative. Quantitative, qualitative. Qualitative meaning is nothing but text data. Text data is nothing but categorical data. Everything are same only. Multiple names they have kept. Why means to confuse. Okay. So anything is same only. Quality, they are going to say the quality. Quality we can't say with respect to feed. For example, you are saying the feedback out of 5, 4.2, 4.3. Now this one is comes under continuous data. That is not considered as a discrete data. Right? Now, for different types of data, we are going to select different types of charts or like this. So for categorical data, we have to go with the bar chart or pie chart like this. So, for example, I have told you earlier, number of how many 0 mobile phones are there? Means 2 are there. How many 1s are there? 5 are there. How many 2 mobile phones are there? 2 are there. That you have to represent using the bar chart or using the pie chart. For example, in this class, gender is the column. Students, I'm having the students data. In that gender is there. Male, 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 female, something I am having. Let us take total, we are having 100 students. Out of which 100 students, we are having 70 students of male, 30 students of female. Okay, this is value. Value is nothing but male and female. Value counts. You have applied the value counts using the pandas. This is pandas. DF of gender. You have selected DF of gender dot value counts, and you have got with respect to output as male 70 and female as 30. This is the output you have got. Okay, completed. This is using the pandas. You have got this one. Now you have to represent the same thing. The same thing you have to represent. How we can represent means on the x-axis we have to take their values. Whatever the categories are there, that you have to represent on the x-axis. Categories with x-axis. That is male and female. On the x-axis, you have to mention the categories. On the y-axis, whatever the value is there, till that the height of the bar should be there. The height, whatever the y value is there, na, here 70 is there, na, up to 70, you have to draw a bar. And this is the male, and this is female. Up to 30, height of 30, of height of 70. Now the same thing you are representing 70, 30 only. Here it is in a tabular format or in the pandas. Now the same thing you are representing using the library, some kind of matplotlib or Seaborn library. You are representing the same thing like this, which is called as bar chart. Now you are using the same thing like this in terms of pie chart, where 70% of the data, 30% is females. 70% are males and 30% are females. The discrete variable will be represented by using the bar chart or pie chart. The discrete variables will be represented in this way, whereas continuous variables will be represented in a different way. For each type of variable, there's different charts are available, right? So now here I'm going to select the next one with respect to continuous variable. Now if you go with the continuous variable, like something like this, we are having different types of weights. Okay, the students' weights are like this. Now here, let us take total 20 students are there, and the weights of the each student is in the LBs. Okay, this is a UK data set where I'm having with respect to the students' weight in the LBs. Now this is a continuous variable or discrete variable. In this, there is no decimal value, but you can't say this is as a discrete because weight, I'm saying clearly the variable name called as weight. Weight can be a continuous, so it is called as continuous variable. So now for continuous variable, we are going to apply the different concept. How we are going to apply means, now whatever the data we are having, this data we are going to take from 9 instead of, if you go with the assume this is a discrete variable. Assume it is a discrete variable. You don't know whether it is a continuous or discrete. You are getting confused. Assume. Now you assume that if it is a continuous variable, what happens? If it is a discrete variable, what happens? Now let us go with the discrete variable. Now discrete variable means, tell me how many categories are there here? How many categories are there? Discrete variable means categories and their count only, na? Tell me what are the how many categories are there here? What are the categories? In this is the data. Column is weight. This is the column. And in that values are 90, 100, 108, 99, 101, 130, 110, 118. Now each of them is a category. Multiple categories are there. Na? So many categories are there. For so many categories, so many bars. For each person, if you are drawing one bar, what you will understand? What is the analysis you will make from that? Now the same thing, if you bring from 90 to 100, 90 to 100, how many students are there in this? 1, 2, 3, 4, 5. 5 students are there. So you draw a bar up to 5. Now 100 to 110. How many students are there? 1, 2, 3, 4. Not this is not 4. 4, 5, 6. Sorry. 6. Okay. 1, 2, 3, 4, 5, 6. 6 people you are writing like this. Now from 110 to 120. 4 students are there. From 120 to 130, 3 students are there. From 130 to 140, 2 students are there. Now, you can analyze more number of students falls between 100 to 110. Now, you can say that one more students. If you go with one student, one bar, what is the analysis? What is the output you are going to say from that? Nothing you can say that. Now, at least I have told you that from 100 to 110, more number of students are there when compared to others. Now, you'll ask me the question, sir, why these bars to be attached? Because 90 to 100, automatically the next one is starting from 100. Now exactly 100 is there, miss, whether it belongs to 90 to 100 or 100 to 110, miss, this will belongs to 100 to 110. Okay, so by default, every bar, the right side part is not included. In the bar, the right side part is not included for the continuous variable. Okay, whatever the bars you are considering this one, this is called as histogram. This is called as histogram. If you draw the bars separately without attaching them, it is called as bar chart. If you combine them, the charts, if you draw the bars side by side, attaching each bar to each of them, it is called as histogram, and this will be applicable only for continuous data. For discrete variable, you have to go with the bar chart. For continuous variable, you have to go with the histogram. For continuous variable, if you go with the if you go with the bar chart, means you can't analyze anything. So for continuous data, we have to go with the differently called as histogram. Sir, some background noise. Guys, others, can you please confirm? Is there any disturbance? Voice is clear? Right? Yeah, please re-log in if you are having any issue because others are saying it is clear. Can you please re-log in? Kinda sound. I think here there is no problem. From my end, there is no problem. Can you please check from your end? It is speaker sound. Okay. Done. So mic sound is little. It is like helicopter. There is noise on the background. There is a little big, yes, background sound. Few students are saying background sound. Few students are not saying. Wi-Fi router. Okay, let me check. 1 minute. USB. Yeah, can you check now? Can you recheck once again now? It is clear? Yeah, done. Okay, fine. Let's continue. So we are having, for a continuous variable, we have to apply the histogram. This is called as histogram. When you are going with the histogram, the right side value of the bar is not included. By convention, means by default. By default, the right, each interval doesn't include the right side endpoint in the bar. So first bar, whatever you are having, 90 to 100, 100 is not included in this. 100 is included in this bar. 110 is included in this bar. 120 is included in this bar. Now for the last bar, automatically last value also included. For the last bar, last value also included. But for the starting remaining bars, the last value is not included. Right? Now, then next one is, sir, for example, if you draw something value like this, sir, you can take some values bars like this, 92. Why to confuse 100, 90 to 100? Instead of going with next number of 100, you go with 101. 101 to 120 and next one 121 like this. Then what happens is 100.5 is there. Then where I have to keep that value? Okay, let us take this value of 100.9999. Then I'm having 999. Then where I have to keep this value? If you take 100.999 and you are taking next number of 101, I'm having 100.999 is where I have to keep. So that is the reason we are going to attach the bars. So you can ask me the question as 100 to 119 only you can correct answer, or 120 to 129. Why to include everything miss 119.7 where I have to keep? That is the problem. Right? For the continuous variables, we have to go with that histogram. Now coming to the time series data. For cross-sectional data, I have shown you that continuous variable, you have to go with the histogram. For discrete variable, you have to go with the bar plot. Okay. Now coming to the time series. For the time series, you have to select with respect to called as time plot. Time plot, which is also called as line plot. As the time changes on the x-axis, you have to go with the time. As the time changes, how the value will change. So you have to take on the x-axis the time value. For example, in Amirpet traffic. Okay, in Amirpet metro, near to the metro, we are having the traffic signals. Now here we are going to color the data with traffic, whatever the number of vehicles it is moving. At morning 6 a.m., at morning 7, at morning 8, 9, 10. As morning 6, the number of vehicles, the traffic will be very low. The number of vehicles will be very low. Okay. Now, whereas at morning 10 o'clock, the traffic will be like this. And again, at after 2 o'clock, again, the traffic will come down. Again, at night 8 o'clock, peaks. So the traffic changes. As the time changes, the traffic, the number of vehicles will be changing. So just you are going to take the traffic, that is time on the x-axis and the value on the y-axis. In the stock market also, we are going to take with respect to date, that is 0110, October 1st, October 2nd, October 3rd. Don't say October 2nd is holiday, sir. Example only. Okay. I also know October 2nd is a holiday. Example only. Okay. For each date, what is the share value? Some share value will be there. After this second day, that share value will increase or decrease. Anything can happen. For example, the share value is 300 rupees. Second day, the share value is 310 miss, the point will be here. If the share value is 290 miss, the point will be here. If the share value is 297 miss, the point will be here. According to that, the point will be there. Now you are going to attach the lines. For example, you are having with respect to on the, if you take the data like this, where you are having October 1st, the value is 300, October 2nd is 302, October 3rd is 305, October 4th is 310, and October 5th is 290, and October 6th is 295. Something you are having like this. Now you have to represent. This is the date column, and this is the value. Whatever the value you are having, the share price value. Now for this, you have to represent a plot miss. Now in this case, you can't apply the histogram. Histogram is applicable only for one column. If you are having only one column called as weight miss, it is going to applicable only on the single column. Whereas bar chart also is applicable only on the single column, where you are having gender, inside that males, females will be there, and you are going to apply on the single column. Whereas time series will be applicable by selecting two columns at a time. We can't apply on the single column. We have to select two columns. One of the columns should be date or time, whatever it is. Second should be the value. So this date should be selected on the x-axis. On the value, that is 300, you are going to point the 300 like this. This is the 300. Next, on the second, October 2nd, 302. You will keep the point like this. Wherever the 302 is there, that point. This is the October 2nd value. After 305, this is the 305 value. After that, 310. Keep the 310. At whatever the 310 is there, at that point, you keep the point. After that, 290. 290. After that, 295. Again, 295. Okay. 290. Assume this is 290 and this is 295. So here the 290 and 290. Now combine this one like this with a line. All the points in the sequential order you have to combine. You can't combine like this as per your choice. You can't combine this one like this. You can't do. You have to come in the sequential order. Okay. You have to come in the sequential. Then it is called as line plot. Line plot means attaching the data points linely is called as line plot. Is that clear? For time series data, we have to go with the line plot or time series plot. This line plot is also called as time series when you are considering the x-axis time. In the x-axis, instead of time, something different is there, means then it is not called as time series plot. On the x-axis, time is there, then it is called as time series plot. Okay, in the x-axis, you are having some different values. As per your choice, 90. For example, I am having a data points like this. X 90, Y 100, 120, 140, now 86, 90. Something you are having. For 90, 100, first data point. 120 versus 140, second data point. 86 versus this one, third data point. Then this is called as not time series plot. If you attach means this is not called as time series plot. For example, from here to here, again you are coming back like this. It is not called as time series plot. Time series plot will be applicable only when you are having the time data on the x-axis. Then only it is called as time series plot. Right? Now, for different type of data, different types of charts we have to apply. We can't apply all the types of charts on the single variable. And if you are selecting only one column, you are selecting only one variable. You are taking one variable and applying the chart or analysis. You are applying the chart or analysis on the single variable at a time. Analysis, you are doing the analysis on a one variable only by selecting one variable at a time. Then it is called as univariate analysis. Univariate. Uni means one, variate means variable. Univariate analysis. This is called as univariate analysis. Analyzing the data, analysis on by selecting two variables at a time. Analyzing, analysis upon one variable upon two variables, upon two variables means by selecting two variables at a time. Then it is called as bivariate analysis. If you are selecting analysis over three variables or more than two variables, whatever the number, more than two variables if you select at a time, then it is called as multivariate analysis. Then it is called as multivariate analysis. A combination of these three is called as exploratory data analysis. Okay, so univariate analysis means selecting only one variable at a time and applying the chart. That is like bar chart, histogram, all this comes under this one. Bivariate analysis is scatter plot, line plot, all this comes under this one. And you are having multivariate analysis with respect to called as heat map. So many things are there. Just forget about these things. Just I want to explain for different types of variables, different types of analysis we have to apply. Right? So for this, we are having multivariate analysis like heat map, tear plot. Example only, not exactly. More detail will go into the, when we are entering into the subject of that one, we'll discuss more. Okay, for different types of data, different types of charts has to be applied. Okay, now, next one is population. Means if you are considering the entire data and you are working, means it is called as population analysis. Population means entire data. For example, I want to take the feedback from the students. Till now, 1 month course has been completed. Now I want to collect the feedback in your batch. Now, total student strength, offline and online, both the strength is around 180 students are there. Now, out of these 180 students, whatever the offline and online, if I'm getting all the 180 feedbacks, then it is called as population data. Now, for example, part of the data I have got. Part of the data only have got the feedback. Means from only 10 students or 20 students only have shared me the feedback. Then I'm working on these 10 students or feedback of these 10 students. Then it is called as sample analysis. The part of the population is called as sample. Sample is nothing but part of the population. It is called as sample. And in real time, we are going to apply on the sample data only. Okay. In real time, we are going to work on the sample. So now what is population means entire set of items. Whatever the complete set, entire data is there, then the entire data is called as population data. If part of the data is only, means for example, here 180 students. If I got 179 students feedback also, it is called as sample only. Till you get the 180, it is called as population. Entire data you have to get. Now still you have got subset only. Within that 180, you have got 179. Out of 180, you have got 179, which is part of the subset. So part of the data, the part of the data is called as sample. In real life, we are going to work only on the sample. Why? Okay. Why we are going to work on the sample? Because the collection of the data is going to take less time. For example, if I ask you to share your feedbacks, miss, after the class, immediately few students are going to share. Tomorrow morning, few students will share. Day after tomorrow, few students will share. And today, whoever I have absent, again, once again, I have to remind for them tomorrow. For example, I assume that one student is absent today and tomorrow also. Whenever all the students are present only, that is possible. Assume that student is not having the recording with him. He is absent and he is not even having the recording. When I will get that feedback? Tomorrow I have to tell. Day after tomorrow I have to tell. Next I have to tell. One more day. 5 days continuation I have told. Assume that particular student is absent on the 5 days. Miss, from that student never I will get, right? I can't remind more than 5 times, right? 6th day again if I remind, miss, what happens? Like this from each and every individual, if you want to collect the data, miss, it is highly impossible. This is an example, small example. Similarly, if you go with real life example, Apple. Okay, Apple wants to go with the, for example, Apple 13 is there. Now they came with the Apple 14. Now from Apple 14, they will have to come with the Apple 15, next generation, in the next year, maybe in the next June or July, whatever it is, they'll get into the Apple 15 series. Now this 15 series, how they are going to develop the 15 series means based on the feedback of the 14. Whatever the feedback they are getting on the 14 series, based on that. Now I assume that this Apple 14 was sold across the world or across India. Let us go with India only. In India, they have sold with number of units are equal to 20 million units they have sold using either Flipkart or Amazon or whatever the offline stores, everything. In entire India, they have sold the 20 million units. Now, whatever they have sold, they are having with respect to their device. Every device will be activated. In that, automatically everyone will open their mail. Now, everyone are having the details. The mail ID is there. Now, if the Apple company asks these 20 million users, they are sending a mail. Your feedback is more important to us. Please take into this survey. It is not going to take more than 2 minutes. Please fill the form. It is going to help us. They have sent a mail. How many of them will open that one? And how many of them will fill that one? And how many of them will ignore that one? Out of these 20 million, if they share a mail means, they will get the reply from only maximum to maximum 5 million. If they have given excellently also, they will get maximum 10 million. That is the max. They have got 10 million means that is max. Highly impossible. 10 million also they can't get. 50% also they can't get, but actually. Now, if they want 20 million, completely they want, every person they want to collect the data, means this Apple has to give some kind of offer. The offer is they'll send a mail in that, please fill the form, and after filling the form, we are going to take some kind of lucky draw. If you win the lucky draw, we'll have 2 days and 3 nights in Goa. Now, instead of 10 million, 15 million will fill the form. They will try for their luck. Maybe they may get the chance to Goa. Na? Assume. Loading and boarding also free inside that. They added that one also. Assume. Now, to collect the data, we have to spend some money. Collecting the data is not free of cost. We have to spend the money. That is the reason we can't work on the little costly. So, whereas sample is less cost, population is more cost. For example, exit poll surveys are there, right? What is meant by exit poll survey? After the election, the persons are going to come out of the polling booth, and now these people, whoever wants to do the survey, they are going to ask to whom, which party you have casted the vote. Some people will say very freely, and that I have casted my vote to Janasena. I have casted my vote with respect to TRS or something they are going to say, right? But some people will ask, what for me? You'll give 1 quarter. They'll ask like this. Nah? They'll not say free of cost. We have to take them side. We have to give 1 bottle after that one also. Before election and after election also. Then only we'll get. Some people will ask, BJP has given 3,000. You'll give 2,000 means I'll get. During that recent elections in Munugodu, 3,000 paid by the BJP and TRS. Now, for exit poll survey, you pay at least 1,000 rupees, I will tell the answer. One people will say like this. Then, if they want to do the survey from complete population, obviously they have to pay the money. Na? So, total 3 lakhs voters are there, assume. Now, from the out of 3 lakh voters, 90% is the pooling was done. Now, miss 2 lakhs 70,000. Now, they want to get from exact and they want to predict the perfect answer. Exactly perfect answer they want to predict means they have to collect all the data from 2 lakh 70 people. But what they will do, they'll just collect from 2 lakh 7, just 270 people, and they will project that TRS is going to win in this area. How many people they ask means only 270 also they will not even ask. Based on the 270, they will predict the answer. In out of these 270, 130 is with TRS and 135 with the BJP, and with respect to remaining whatever you are having 35 with others. They will say this particular area is very tough. Unable to predict properly. We can't say. If they get with respect to this one as 150 and this one as 125 like this means, they will say that TRS blindly or BJP, whatever it is. Like this they are going to do. Sir, if they are doing perfect survey, means they are collecting from all the population data, entire population data, then no need to count, then no need to have a special day for counting separately. Based on this only, we can directly conclude the answer now. Why separately counting, again opening that all the EVM machines and again counting? So why they are doing? Because they are doing only on the sample analysis. Now each TV channel, this TV number 1, okay, TV channel number 1, whether it is available or not also, I don't know. Just example I'm writing, TV 1, TV channel number 2. Assume this TV channel is for of TRS, okay, and whatever TRS does wrong also, it will project in a right way only. Assume this is the channel like this. Now it will project that next CM is KCR only. It will project like this. This channel is for of TDP, yellow media. Now this will project always CBN is the next upcoming later. If you go with the channel number 3, Sakshi, I know the answer for this. This is very clear for me. In this, it will say only Jagan only, always the best. Though he do mistake also, it will say this is the best only. Every person will do the mistake, but it will not project the mistakes. It will only project the highlights. Now, and in this particular exit poll survey, now this particular, for example, during the previous elections, out of 175, TDP has got only 23 seats. And whereas with respect to YSRCP has got 151. But in the exit poll survey, they have told with respect to 70 will be with TDP, 80 will be with TDP, and yellow media like ETV and ABN has projected 120 with TDP, something they have told. Now from where they have got all these values, just by applying the sampling. Sir, sampling means then whatever the TV channel 1 is showing, others also should show almost same, but by huge deviation is there means they are doing the bias sampling. Bias sampling means they will collect only from their data. For example, I am from TDP, assume. I am working in the TV2. Okay, I will ask you to whom you have voted. You told that YSRCP. No, I will not collect the data from you. Go away. You told TDP means I will write your name. Please tell me your name and phone number and I will write your name. I will collect only this data and I will project myself. TDP is the winner. Collecting the data also wrongly collecting the data, which is called as bias sampling. If you are collecting the data properly, it is called as unbiased, which is called as non-random sampling. So random sampling is there, non-random sampling is there. Non-random sampling is also called as bias sampling. Who will do the bias sampling means, for example, you are working in the channel and your MD has told you that you have to collect this data means what is the other option you are having? You can't do anything, right? You have to collect only. For example, you are asking with the sir, SRK's feedback should be 4.5. Okay, SRK's feedback is average feedback score is 4.5 out of 5. Now, whoever the students are giving me 4.6, 4.9, 4.2, I will only collect those. One student has given me only 2.5, delete. Shift delete. Automatically, I will get the answer 4.5. Fine, I fixed my answer. For that only, I will collect the data. According to that, I will collect the data. Answer is fixed. According to that. Now, example is, one of the example, live example is police department also. Is there any police department people here? Any family background of police here? Nothing, na? Then I can explain this example. No problem. Okay, in the police department, if the person is a criminal and he is not having any money and the police wants to prove that he is a criminal means he'll collect all the evidences. If he wants to prove that he is not criminal means he'll not even collect one evidence also. He'll say to the court that no evidence is found. Judge will say, go out, enjoy. Purely police will do that one. Nah? That is bias sampling. So we are having different types of sampling techniques. And based on the sample, all the bias sampling will be done outside. But inside the IT industry, only random sampling will be done. We can't go with the unbiased, biased sampling. We have to go with random sampling only. So we are having two types of sampling techniques. One is called as random. One is called as biased, right? And based on the sample data, you are estimating the population. Means out of 3 lakh voters, assume this is the population size. You have collected the sample from 3,000 people. And out of 3,000 people, you are predicting who is going to win in that particular area. Means based on the sample, you are estimating the population. Since you have collected the data of 3,000 and out of this 3,000, TRS is the highest you are having, means you are assuming the entire population also has casted their vote towards the TRS only. Based on the sample, you are estimating the population is called as inferential statistics. Inferential statistics. Inferential statistics means nothing but inferencing. Inferencing. Inferential means inferencing. Inferencing means nothing but estimating. Okay. Using the sample, you are estimating the population. Using the sample, you are estimating the population is called as inferential statistics. Without estimating, just directly you are doing the descriptive, then it is called as descriptive statistics. This sampling techniques we'll see in the later class furtherly. When we are discussing about the inferential statistics, at the time I'll explain the sampling techniques. Now within the statistics, we are having two types of statistics. One is called as inferential and second one is called as descriptive. Inferential statistics, descriptive statistics means just collect the data and describe them. What is the average value? What is the variance value, standard deviation value? Some things will be there. You have to calculate those things. For example, you are collecting the data. In this class, you are collecting the data of students and you are taking with respect to how many male students are there, how many female students are there. That is nothing but count. You are counting them. Total count. You are doing the total count. And just you are calculating the total count is nothing but describing the data. First, you are going to collect the data and you are going to describe the data. Then it is called as descriptive statistics. And based on the sample data, you are inferencing or estimating or you are concluding something on the population, about the population based on the sample. Then it is called as inferential statistics. That is the difference between descriptive and inferential. Right? Now, coming to the first one, descriptive statistics. First, we'll start with the descriptive statistics, followed by the inferential statistics. Now, whether it is a descriptive or whether it is a descriptive statistics or inferential statistics, statistics is nothing but measuring and analyzing. Statistics means nothing but measure and analyze. If you are measuring the data, you are measuring whatever the values you are measuring on the population data. If you are measuring the data on the population, then it is called as parameter. If you are measuring anything on the population data, you are measuring on population data. If you are measuring on population data, then it is called as parameter. Means if you have calculated the average value on the population data or sample data. If you are applying the average on the population data, this average is called as parameter. If you are measuring the same average on the sample data, if you are measuring, then it is called as statistic. It is called as statistic. The same average will not be the average will be the same. The only difference is on the population data, on the sample data. If you are measuring on the population data, means it is called as parameter. If you are measuring on the sample data, it is called as statistic. Right? Now, in that first one, measures. Out of the measures, we are having 4 different types of measures. 4 types of measures are there. And first measure is nothing but measure of central tendency. Measure of central tendency. Second measure, whatever the second measure is there, the second measure is called as measure of spread. Measure of spread. How the data has been spread, that is going to measure. Whether the data has been large spread or small spread is there. Okay, that we are going to measure. Then it is called as measures of spread. Okay, the third one is with respect to shape. Measures of shape. How the entire shape of the distribution of the data is there. How the data has been distributed. How the shape of the data is there. That is is the third one. That is measures of shape. Third one and fourth one. Third and fourth will give the measures of shape. Both. Right? So let us start with the first one called as measures of central tendency. Now measures of central tendency means nothing but tendency. Tendency means generally. We'll do generally. Central means center area. Okay, middle area, middle one, right? Middle one, which is called as central tendency. Sir, can you explain once again? First one, second one. Oh yeah, you can write. First measure is called as measures of central tendency. Second one is called as measures of spread. Third one and fourth one is called as measures of shape. Each one in detail we are going to. I'm going to explain each one detailedly. What is meant by measures of central tendency? What is meant? Everything we'll see one by one. How we have to measure the central tendency, how to measure the spread, how to measure the shape. Everything we'll see in the detail. Okay. Now, first one is measures of central tendency. Inside that, we are going to calculate the center value. Center value. So, center values, measures of central tendency we are having with mode, median, and mean. These are the three things: mean, median, mode. Okay. Mode is nothing but most repeated value. Mode means the first one called as mode, most repeated value. Second one, median and mean. So let us start with the first one called as median. Take the heading as median. Median will refer to the data which is in the center position. Which is in the center position of the order. Order means now whatever the data you are having, first you keep in the order. For example, let us take here 5 chairs are there. Assume these are the chairs. 5 chairs are there. What is in this center one? This one only, right? Now, who is sitting in this chair? That one is called as median. Whatever the person is sitting in this chair, he is called as median. Whether irrespective of value. Irrespective of value. Okay, whatever irrespective of value. Forget about their value. Who is sitting in the center position? It is called as median. So here I am having the data. This is the data where I am having 154, 139, 154 like this. Now this entire data first I have to make in the order way. In this order, whatever is in the center position, this is considered as the median. The center position is considered as the median, and you can get the by using the formula n plus 1 divided by 2. That is number of data points plus 1 divided by 2. Here I am having 9 data points. 9 plus 1 divided by 2. The center position value is 154 for this example. Now let us assume we are having 10 values. 10 values are there. 10 plus 1 divided by 2 means 5.5. You are going to get 5.5. 5.5 means center 2 values you have to take the average. That is 5th position value and 6th position. Average of 5 plus 6 is called as 5.5. So 5th position and 6th position average you have to consider. So the 5th position value is 154 and 155. Center 2 values average you have to take. In order to get the 5.5, 5 plus 6 divided by 2 you have to do. That is 5th position value and 6th position value. Sir, in the first position, let us assume 0 is there, sir. Still the answer will remain same. In the second position, 2 is there, sir. Still the answer will remain same. I am focusing only on the position, not on the value. In the center position, whatever is the position, not on the value. Now, if you go with the second one called as mean. Now, mean is nothing but sum of the data points divided by total number of data points is called as mean. Sum of the data points divided by total number of data points is called as mean, where you are having with respect to sum of the data point. Now here, if you go with this one, if you add all the values and if you take the value and if you do the average, you'll get certain value. You'll get some value. If this value changes 0, automatically mean will change. If this value changes, mean will change. Mean is dependent on the value. Now what is meant by mean and median means mean is called as center value. Mean only. Mean is called as center value, whereas median is called as center position value. Median is called as center position. In that position, whatever the value is there, that value. Whereas mean is called as center value. Average value will be in the center, obviously. Average value from here to here, if you consider, average means center only, na? Center is called as average. How much distance you are having towards the left, same distance will be there towards the right. It is called as center position. Now this is focusing on the value. Center value is called as mean. Center position value is called as median. Irrespective of value, in that position, whatever is there. That is the difference. Now, if you calculate for this example, same 10 values, you take the same 10 values and calculate the mean. That is 139 plus 140 plus 154 plus 154. If you calculate the average, okay, if you go with this 9 plus 4 plus 4, 17, 21, 26, 28, 30, 32, 38. 6, 10, 15, 20, 25, 30, 38, 47, 56, 65. 6, 16. 1658 divided by 10, which is 165.8. Okay, if you go with the average value, that average value tells you the center value, how much it is having from the center. Now, for example, you are having with a batsman in the cricket, like Virat Kohli. Okay, now Virat Kohli, match number 1, he has played with 54 runs. Match number 2, 38 runs. Match number 4, 44 runs. Match number 3, 4. Now this time he has done with 46 runs. Now 46, 90, 128, 128 plus 2. 128, 132, 182, and match 5, 18. Total is 200. Now average is divided by 5, which is 40. This is the average. Average means now the center value. It is in the center position. What is meant by center value means the meaning of center value is equally distributed. If you do with respect to 50 minus 40, 38 minus 40, 40, 44 minus 40, if you do the 40 for every value, and if you do the total, it is going to be 0. That is 14 minus 2 plus 4, and this is plus 6. This is minus 22. Right? So we are having the positive value plus 24 minus 24. The sum is 0. The distance from the right side, that is positive values, and the distance of negative values will be the same. Plus 24 minus 24. If you do the positive values total, 24. If you do the total of minus, will be also 24 only. That is the mean. Mean means center value. Whereas for the same data, center position value, first you have to make this one as an order. That is 44, 46, 18, 54. Now this is center position value. This is median. 44 is the median. Mean is 40. 40 is the mean. Right? So mean value is nothing but sum of the values divided by the total number of data points. Now if you are applying on the population data, then it is called as population mean. If you are applying on the sample data, it is called as sample mean. Similar median also. Population median and sample median. Any parameter, anything. If you are applying on the sample means sample parameter. If you are applying on the population means population. For the mean, population mean is represented by mu. The population mean is represented by mu. Whereas sample mean, if you are working on the same thing on the sample data, then it is represented by x bar. It is represented by x bar. This is the sample mean, x bar. Whereas population mean is represented by mu. Whereas coming to this median, there is no special symbol for that. For median, there is no symbol. For whereas mean, we are having the symbol. The symbol is mu and x bar. All the population data will be represented by Greek letters. All the population data will be represented by Greek letters. All the sample will be represented by English letters. Now, in the entire statistics. In the entire statistics, all the population will be represented by Greek and all the samples will be represented by English. Okay. So this is called as mean. Now, whatever the mean we have taken, it is called as arithmetic mean. Arithmetic mean. Arithmetic mean means x1 plus x2 plus all the data points like this up to xn divided by n, total number of data points. Now, if you are going with respect to the next one called as weighted mean. Weighted mean. Weighted mean means here in the above case, for example, you are taking the values like this, some values like 60 and 80. You are having to, this is the marks. You have secured the marks like 60 and 80. What is the average mark? 70. 70 is the average. Okay. You are taking the average as 70. Whether it is a mu means mu, x bar means x bar. Whether it is a population data means mu, if it is sample data means x bar, whatever it is. Now you are having the average as 70. Fine. Now here you have given the weightage for both of them of same. But it is your internal marks. This is your external marks. In the internal marks, you have to give only 40% weightage. For external marks, you have to give the 60% weightage. The weightages are not same. If you are considering both of them of same weightage, that is 50-50 weightage means arithmetic mean. But you are giving the different weightages means, then it is called as weighted mean. Weighted mean means you have to multiply with their weightages, marks into their weightage. That is 60 into 0.4, which is 24. 0.80 into 0.6, which is 48. Now the total is, which is nothing but 72. This is weighted mean. Weighted mean means different weights for the each value. Earlier case, whatever you have considered for 60 and 80 separately like this, 60 and 80 into 0.5. This you have given 0.5. This one also you have given the 0.5. That is the reason you have got 30 and 40 and total is 70. But this time you are giving the different weightages. For first one, you are giving a different weightage. Second one, you are giving the different weightage. So when you are giving the different weightage, the mean will change accordingly, which is called as weighted mean. In your internal marks, external marks, in your BTech or BSc, whatever it is, degree completed, right? So at that time, we are having internal weightage, some marks for assignment, some marks for attendance, some marks for with respect to for this one. All these things we used to have, right? So the corresponding weightage they are going to multiply. Whatever the weightage they have given for that, they are multiplying that one. For example, you are having two internal exams, two internals and assignment and attendance. Attendance is given 5% weightage. Okay, assignments are given 5% weightage. This one was given 20% weightage. And external was given with 70% weightage. Assume. These are the different weights. You have got out of 100, in the two externals, you have got out of 100 with 80 marks. In the assignments, out of 100, you have got with 90. In the attendance, you have got 100. In the external exam, you have got 60. Something like this. Now, what is your total miss? You have to multiply with 80 into 0.2. That is 16 marks are considered out of 100 for internal. Okay. And you have got with 90 into 0.05, that is 4.5 for your assignments. Similarly, 5 that is 0.05 into 100, which is nothing but 5 marks. So out of 30 marks you have got with respect to 25.5 in your internals. In the external, 60 into 70, that is 0.6 into 70, which is 42. Total is 67.5. Round figure it is to 68. If you make round figure. Right? Now you will get like this in terms of. Now each one is having a different weightage. Now whatever you have done is weight into the value. Whatever the value is there. Weight into value. That is W into X. The weight into the value. W into X. And all the values you have added. That is summation. Summation of weight into X. Divided by summation of weights. Automatically the down part will be 1 only. Summation of the weights is equal to 1. So the same example I have represented here also. You can go through the notes where weighted average is taken as sigma W into X divided by sigma W. Now, if the same thing W into X, for each one record only you are considering miss W into X. 2 records you are considering and adding miss sum. Sum is nothing but this one, sigma. Now, if you write here 1, I is equal to 1 to N, means what is the meaning? How many records are there? For example, 5 records are there. W1 X1, W2 X2, W3 X3, W4 X4, W5 X5. Where you have to start? First number where you have to start, and for last number where you have to end. That will be represented here. So W5 X5. If N is equal to 5 means this is the one. So what is this same representation? the entire equation, this one, we are going to represent like this. Instead of writing the entire equation like this, we are just representing sigma of wi xi, I is equal to 1 to 5 only, because up to 5 only I'm considering. Okay. Now, similarly, sigma I is equal to 1 to n wi xi. What is the meaning of this one? w1 x1 starting is 1 na, w1 x1, w2 x2, like this on up to wn xn. The same thing you are representing like this. Now, since every time I is equal to 1 to n, no need to represent separately. Automatically it is 1 to n only. Unless you write number miss, you have to represent. Otherwise, by default, it is 1 to n only. Sigma wi xi, if you write like this also, it is sufficient. You don't need to specially write 1 to n. Automatically starting to ending. Everything you have to consider. If you want to start from 2, separately you want to start from 2 miss, you have to write. Separately you want to do anything miss, you have to write. By default, it is equal to 1 and this is equal to n by default. Default parameter is 1 and n. You don't need to specially mention that one. That is sigma wi xi divided by sigma wi is the weighted mean. So here, if you consider the example like this, suppose your midterm score is 83 and your final exam score is 95. You have given the 40% weightage for midterm and 60% weightage for the final one. The total of weight should be 1. The total of weight should be equal to 100%. Percentage means 100%. If you are considering value wise means 0.4, 0.6 means total should be 1. Value wise, total should be 1. Percentage wise, 100%. Weight should be always equal to 100%. Then compute the average value of the scores. So here you are going to write 83 into 0.4, 95 into 0.6, because 83 you have got in the midterm, the weightage of midterm is 40. 95 you got in the external, so that weightage is 60. You are just multiplying that one, sigma wi xi. This is w and x, w x. That is x into w x. This is x1 w1, x2 w2. Right? So the x value into the weight divided by w1 plus w2. Denominator is sum of the weights. Formula is sigma wi xi divided by sigma w I. I means nothing but starting to ending. So you don't need to specially mention that one also. If you write like this also, it is sufficient. Okay, sigma w into x divided by sigma w, which is given as the weighted mean. What is the difference of arithmetic mean and weighted mean is, for example, if you are going example number 1, 20, 30, 40. Now, what is the average of these three? Average means nothing but summation divided by n. Sum is nothing but 90 divided by 3, which is equal to 30. This is normal mean. Weighted mean means equal to, how many are there? 3 values are there. 1 divided by 3, which is everything of weight of 0.33. 30 into 0.33, 40 into 0.33. Arithmetic mean means nothing but giving the weightage for all the records of same is called as arithmetic mean. Different weightages means weighted mean. Weight is same is arithmetic mean. So 20 into 0.3, which is equal to 6.66. This is 9.99. This is 12.66. If you add total, it is again 30. The same thing. Here and here both are same. The only difference is you are giving all them on the same weightage. Is called as arithmetic mean. If all the weightages are same, for example, sigma wi xi divided by wi, sigma of wi. Now wi x1, so w1 x1 plus w2 x2 plus w3 x3. Assume 3 values are there. Divide by w1 plus w2 plus w3. Now, if all the weights are same, can I take w as the common? All the weights are same only, na? W weights are w. I can write this one also w, w, w. 3 w's. No need to write 1, 1, 1 separately. W if I take common, x1 plus x2 plus x3 divided by 3w. W cancel. x1 plus x2 plus x3 divided by 3. Which is called as arithmetic mean. If all the weights are equal, then it is called as arithmetic mean. If the weights are different, then it is called as weighted mean. That is the only difference. between the arithmetic mean and weighted mean. This concept is one of the most important concepts in the artificial intelligence. This will be correlated directly in the artificial intelligence. At the time, I'm not going to explain once again. Right? Whatever the doubts you are having, you have to ask now only. Again, I'm not going to repeat the same topic furtherly. Right? Next, how to do this coding, that we'll see in the coding part. Now I'm doing the theoretical part followed by the coding part. In the coding, again, we'll do the same thing, everything, how to calculate the arithmetic mean, weighted mean or median, everything we'll see with the coding, everything one by one. That too in the Python only, completely. Right? Next one is mode. Mode is nothing but most repeated value. Okay, whichever is the most repeated value, that is called as mode. In my case, I'm having, this is the data set, where in this data set, the 154 was repeated 3 times. I'm writing for each category and how many times it has been repeated. Each value and their repetition. Value and their repetition. Value and their repetition. In my case, I'm having 3 154s. So the mode is 154. For this example, it is 154. Now assume that 154 3 times are there. Okay, let us take, this is the data set. For this 154 is the answer completed. Now let us change the different data set. Next data set number 2. In that data set, along these values, 192 also is there. One more value. Now tell me how many with respect to 154 was repeated 3 times. Now along with that 132 also one more person is there. Now 192, 1%, 2%, 3%. Now 192 also having 3 persons. 154 is there, 192 also 3 persons. Both are there. Now then it is called as bimodal. Both of them are modes. 154 and 192. Both of them are modes. If in your notes you can write, if in the data set, if in data set only one mode is there, only one mode means, then it is called as unimodal. Unimodal data. Whatever the unimodal data. If in your data set, if in data set 2 modes are available, if 2 modes are available, then it is called as bimodal data. If in data set more than 2 modes are there, then it is called as multimodal data. If in the data set you are having 0 modes, none of them is repeated, everything are unique only. For example, 132, 135, 138, only 3 numbers are there. What is the mode for this? None of them was repeated. Not even one is repeated. What is meant by mode? Which was most repeated one. Here no repetition is there. Most repeated one, second. Here no repetition only is there. I'm having only 3 values, in that no repetition also is there. Then there is no mode. In this case, no mode. None of the values repeated means no mode. It is no mode, or everything are repeated one time only. Everything has to be considered as the mode only. Equal number of times everything was repeated, right? So which was most repeated, that particular value is called as mode. And we are going to apply mean and median. These both of them we are going to apply on the continuous data, whereas mode will be applied on the discrete data. For example, male and female. What is the average of male and female? Transgender. No, right? That is not called as average value, right? Or median value. What is the median value out of this? So we are not going to have the median value or mean value for the discrete variables. For the discrete variable, we can't find. We can't find for the discrete variable, we can't identify the mean or median. We can apply only for the continuous data, mean or median, not for the discrete data. Is that clear? Now, next one is called as measures of spread. It is also called as measures of dispersion. Measures of spread or measures of dispersion. Right? The second one is measures of spread or measures of dispersion. In this, we are going to check how the data has been distributed from the starting to ending. That is from the range by calculating the maximum value and minimum value. This is the range it has been, the data was given. The spread, how the data has been spread in the given data set. That is, we are going to identify by using the measures of spread example by using the range. Range is nothing but maximum minus minimum. In the given data set, whatever the maximum value is there, minus minimum value. This is called as range. All the data points are between the 57 from the starting of this one. Within the 57 points only, it is the values are there. It is called as range. And the next one is called as deviation. Deviation means how much it is deviated from the mean. Because we can't, for example, in this class, we are having with respect to marks of the students. So all the students, I have kept some entrance exam, some examination. Okay, some kind of based on the core Python or using the pandas, I have kept an exam. And in that, all the students has got 80, 70, 74, 76, 92, 75, 86, something. Yeah, the students has got like this, the values. Now, average value, if I calculate the average value, something 80 is the average value. Assume, I didn't calculate it, example on. Okay, so 80 is the average value. Now, for this 80, how much each student was deviated from the mean value. I'm not going to calculate from the topper. I'm not going to calculate from the bottom one. I'm not going with respect to minimum value. I'm not going with respect to from the maximum value. I'm calculating how much each student has deviated from the average. And I'm going to say you are above average student or below average student, like that. I'm going to use based on the average value, how much you are deviated from the average. So average deviation from the average, that is x minus x bar, is called as deviation. Deviation means x minus x bar. So for simple example, 1, 2, 3, 4, 5. I'm writing simple example 1, 2, 3, 4, 5 because calculation is easy. X bar is equal to 3 and x minus x bar is nothing but for each value 1 minus 3, that is minus 2. 2 minus 3 minus 1. 3 minus 3 0. 4 minus 3 plus 1. 5 minus 3 plus 2. These all of them are called as deviations. This one is called as deviation, 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 deviation. And if you do the sum of all the deviations, if you do the sum, then it is called as sum of deviations. In this case, what is the sum of the deviations? 0. This is called as sum of deviations, sum. Now the same thing, you are calculating the sum divided by total number of data points. Now that is called as mean deviation. Deviations, for that you are applying the mean. Mean means nothing but sum. Sum divided by total number of. First you are calculating the deviations. After the deviations, you are calculating the sum divided by total number of data points. That is called as mean deviation. Is that clear? Now, deviations are clear. Now, in the given data set, for example, I'm having with respect to students like this, 40. One student has got 40. One student has got with respect to 60. And one student has got 90. Only 3 students are there and these are the marks. Okay. This is example number 1. In the example number 2 also, same 3 students are there. This time, student has got 80. One student has got 80. Second student also got the same 78 and third student has got the 82. Okay. Now, if you calculate how much the students are deviated, more, where the deviation is more? In this or in this? Between the students, the difference between the students, in which case it is more? In the first example, the deviations are more. And if you calculate the average deviation means difference from the mean. If you calculate the average deviation in both the cases, it is equal to 0 only. Just if you want to, you can calculate. So I'm going to take this one as 80. For simple example, 40, 60, 80, which is nothing but 180 divided by 3, 60. Deviation is nothing but 40 minus 60, which is minus 20. 60 minus 60, 0. Plus 60, minus 60. That is 20. What is the average deviation? 0. Miss, there is no deviation. Huh? There is no deviation. Huh? Average deviation 0 means there is no deviation. Huh? Now in this case, what is the average value? 80. 80 minus 80, 0. 80 minus 80, that is minus 2. Minus 80 plus 2. What is the average? 0. Means in this also no deviation. Huh? And both of them are equal. Huh? These 3 students are equal and these 3 students are also equal. So the mean deviation is having the problem because if you measure from the center, automatically every value will be the same distance. Because that is called a center value. From the center you are comparing means automatically the left side, how much left side is there, right side also will be the same. If you take your hand like this, if you see from the center part, the distance from here to here, it will be the same. That is the reason it is called a center part. Otherwise, why it is called a center part? Why it is called a center part? Why it is called a center? Whatever the part is the center position, why it is called a center? Because the distances are same. Right side and left side. It is called a center. Now, if you measure from the center, automatically this one or this one, the mean deviations will get 0. If the mean deviations are 0, means deviations are not there. Everything are same. So that is the reason we have to do some, whatever the negative values are there, we have to convert them to the positive values. Now, what I'm going to do is just observe this example, same example. Okay. Same example, I'll keep like this as it is. Instead of keeping like this, I'm going to move towards the right side because the distance will not be sufficient. Example number 2. What are the numbers? 78, 80, and 82. Okay. Where minus 80, minus 80, minus 80, which is minus 2, 0, plus 2. And the sum of the deviations is equal to 0 and mean is also equal to 0. Obviously, sum is 0 means automatically mean also will be 0. In this case, the mean deviation is getting 0 because you are doing x minus x bar. These values are nothing but x minus x bar, and if you are doing the summation of x minus x bar divided by n means it is equal to 0. Here also you are doing the summation of x minus x bar divided by n, which is equal to 0. In this case, you are doing the same. Now deviations, since positive deviations and negative deviations both are cancelling off. Now you know that this is having a large deviation, this is having a less deviation. But how? Here average deviation is getting 0 means we are not having any value now. So each value has to be converted to positive value. To convert the positive value, what I'm going to do is x minus x bar whole square. I'm going to convert to whole square. That is nothing but 400, 0 and 400. Now the total is going to be x minus x bar whole square divided by n. If you take like this, that is, let us take this is a population data. Let us represent by population data, everything. Okay, let me represent by using the population data. Assume this is a population data. Now mean deviation is 0. Now you are having with respect to x minus mu whole square divided by caps lock n is nothing but total is equal to 1000 divided by 3, which is nothing but 333.33. Now this one, summation of x minus mu whole square divided by n is nothing but that is 4. First x minus x bar whole square or x minus mu whole square, which is nothing but 4, 0, 4. So total is 10 divided by 3, which is nothing but 3.33. From this we can conclude that deviation is more in this case and deviation is very less in this case. Here 800. Okay. Here also 8 only. That one also 8 only. This one also 8 only. Both are same. Okay. So 800 by 3 means, which is nothing but 233. 233 and this is 2.33. Okay. So from this we can clearly conclude that these deviations are very low. This particular deviations in the example number 2 is very low when compared to the example number 1. When you are doing the square only, you can identify this one. Now, whatever the value you have got, this value that is squaring of that one and you have done the mean. First, what you have taken? Deviation. For that deviation, what you have applied? Square. After that, you have what you applied? Mean. Right? So, first you have taken the First you have taken the deviation. Deviation is nothing but this one, that is x minus x bar. Please observe this one very clearly. X, that is x minus mu. First you have taken x minus mu. After that you have applied the square of that. For each and every value you have done the same. Finally you have calculated the mean value. Means first you have taken the deviation. For the deviation you have applied the square. For the square, after applying the square you have done the mean. So this is called as mean square deviation. Earlier it is only the mean deviation. Now it is mean square deviation. Once again, please focus once again. X, only x minus mu is called as deviation. Don't write simultaneously along with me. First you focus on the board. Later I will give the time for writing, because this is one of the most important. Okay, x minus mu is called as deviation. X minus mu and sigma by n, if you apply like this, it is called as mean deviation. Right? Similarly, x minus mu is called as deviation. X minus mu whole square, then it is called as square deviation. And sigma of x minus mu divided by n, that is total of square deviations total divided by n is nothing but mean square deviation. The formula is like this. No need to by heart the formulas. Deviation square mean square deviation. This is also called as variance. This is only variance, miss. Variance or mean square deviation both are same. Variance and mean square deviation both are same. Right? Now, just if you apply the concept whatever earlier I have told you, that is marks with respect to 40, 60, 80. These are the various marks. And you have calculated what is this marks? Units is, what is the unit? M only, na? Marks will be represented by M. So marks. Now deviation, that is x minus mu, that is 40 marks minus 60 marks, which is nothing but minus 20 marks. 60 minus 60 marks, nothing but 0 marks. 80 minus 60 marks, within nothing but 20 marks. Now if you are doing x minus mu whole square, 20 marks minus 20 marks whole square, which is nothing but 400 marks square. 0 marks whole square is nothing but 0 marks square. 20 marks square whole square is nothing but again 400 marks square. Now if you apply the square average, that is 800 marks square divided by 3, which is 233.33 marks square. I'm getting the units are also squared off. Now that units should not be squared off, means what I have to do is I have to apply the square root for this. If you apply the square root for this, now again if you bring, now you will bring back again to the units to the original position. So why you are squaring and why you are bringing back? If I don't square, what happens? The mean deviation I am getting 0. Since the mean deviation is getting 0, that is the reason I am doing the square. If I am doing the square, what is the problem? Units are also getting squared. First time, if I am not doing the squareness, mean deviation is getting the problem. After that, what I am doing is squaring. Now squaring means units are getting squared. Now again the units to get to get back to the original units, I am applying the square root. That is this one. This is called as standard deviation. This is called as standard deviation. This is actual deviation. Standard one is this one. To measure the deviation, we have to go with the standard values. But the standard values, how we can get directly by based on the deviation, normally we can't get it. We have to use with respect to like this. Why we are squaring? Because the negative values has to be converted to positive. Why we have to convert? What happens if you don't convert? Means it is going to be mean value is going to be the 0. Mean deviation is going to be the 0. That is the interview question. In the interview, they are not going to ask you the what is the variance formula. Why variance is having the square? Why you have to apply the square on that? Just I can explain, this is called as how I have explained for the mean. Mean is called as sum of the numbers divided by n is called as mean. Similarly, I can write the formula for variance also, square root that is sigma into x minus mu whole square divided by n, and standard deviation is called as square root of variance. I can write directly the formulas also. Na? Why I have to explain all these things? Because we have to understand how the entire deviation is there. Okay, sir, you told the deviation, very clear, sir. Excellent, marvelous. But what is the use of this standard deviation? Now, for example, in the IPL auction, everyone knows IPL and everyone knows the auction. And we are going, that franchise people are going to purchase the cricketers who are going to play on behalf of them. Now, in the IPL auction, we have to go with, I'm having two players. One is called as Chris Gale and one is called as Virat Kohli. Two players are there. And the previous matches, match 1, match 2, match 2, match 3, match 4, match 5. 5 matches they have played. Both of them, last 5 records I'm taking. Now, Chris Gale, in the first match, he has played 100. Second match, duck out. Third match, 23. Fourth match, 27. Fifth match, 50. Total is 200. Virat Kohli, first match 54, 46, 38, and 48, and next one is 42, next one is 60. Total is 100. So let us take 42, 10, 200. This is also 200. Both of them 200. Sum is totally same. Now sum is same is automatically average also will be the same. Na? Batting average will be 50, batting average also 50. Average is also same. Now, if you are a franchise person and you want to purchase out of these two players, which one you are going to select? Whom you are going to select? Virat Kohli or Chris Gale? Why? Patriotism. Nothing. Na? Just you are going to see the consistency. What is meant by consistency? Means nothing but standard deviation. Who is having the less deviation, that player we are going to select. Calculate the standard deviation for both of them, and you will find the standard deviation for Virat Kohli will be very less when compared to Chris Gale. Consistency is the word is meaning is deviation. Less deviation is called as consistency. In the IPL auction, standard deviation is one of the most important parameters for selecting. Not only in the IPL auction, even in selecting in the IPL, World Cup cricket team also, the same thing. For anything, they are going to work on the same concept called as standard deviation. And the same standard deviation we are going to analyze in the further class also. Now, for the population data, the variance is given by the formula called as sigma of x minus mu whole square divided by n. Standard deviation is given by the formula called as square root of x minus mu whole square divided by n. But whereas for sample, if you go with sample, variance is given by the formula x minus x bar whole square. Instead of mu, you have to go with x minus x bar whole square divided by, instead of caps lock n, you have to go with the small n. That is sample data. It will be represented by small n. Population data is represented by caps lock n. Minus 1. You have to add minus 1. Similarly, for standard deviation, you have to go with x minus x bar whole square divided by n minus 1 square root of. Now, why we have to consider n minus 1? Why we can't go with only n? Is called as bezel correction. That is one of the interview question along with the certification question. In TCS exam, it is mandatory. In the TCS exam, they are going to ask why you are considering n minus 1. I will explain the reason. Before to that, please write the notes. And representation also, it is given by sigma square. And this is sigma. That is square root of this one. This is s square and this is s. representation will be done by like this. This is given by sigma square. And this is sigma, this is s square, and this is s. Right? And last one, yn minus 1. That is the last topic. In next 2 minutes or 3 minutes, it will be completed. Just only 2 minutes. Okay. Done? Up to this, done? Now the last one, yn minus 1. We are going to conclude with this, yn minus 1. Yn minus 1 we have to take miss. For example, you are having x plus y plus z is equal to 30. What are the different values of x and y and z is possible? 10, 10, 10 is one of the option. 11, 9, 10, second option. 12, 8, 10, third option. Like this, infinite number of options are there. Infinite number of options will be there. You can take even 100, 200, and minus 270 also. Z is minus 270. Any value you can take now. There is no rule that everything should be the same, right? Now, if I write first value as 10, y plus z is equal to 30. Now, what are the different values of y and z is possible? Again, you can take multiple values. Infinite values are there. You can write even 15, 5, 7, 13, 2 and 18 like this. But if I write this second value also 8, what is the option? Now there is no choice for you. You have to go with the value only. Every time one will be left out with no choice. That is called as Bessel correction. Of course, you will be not satisfied with an example. I will explain with one more example. Okay. Now you are having with you 7 shirts are there. 7 dresses, not shirts. So girls also will be satisfied. 7 dresses are there with you. Okay. Now 7 dresses are there. And we are having with respect to Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now you are having like this. Now on the Sunday, how many options you are having? Miss 7 options. On the Monday, if you wash and again if you keep miss again 7 options, but not repeated. No repetition is allowed. Now repetition is not allowed means you'll have only 6. How many options? 4, 3, 2. This is not called option. It is called as mandatory. This is not called as option. Option means you have to give at least 2, then only we can select in that. Then it is called as option or choice. Choosing, you show one finger and select miss. Then it is called as mandatory. We have to touch only. There is no other option for us. If you show 2 fingers and asking to touch one finger miss, okay, then it is called as choice or option. This is called as mandatory. Every time one will be left out with no choice. That is called as Bessel correction. For the sample data, one will be left out with no choice. Whenever you are applying on the sample data. That is the reason we have to go with n-1 in the sample data. Right? So that is the end of the session.